So my name's Michael Stringer. I'm a public sector architect from Melbourne in the public sector team. And our talk today is on automated security remediation. I'm also very glad to be joined today by Jason Gorringe and Ahmed Al-Anim from Australia Post. First, I'll talk about why we should do automated remediation. And then they'll talk about how they do it in the real world, protecting Australia Post's workloads and assets in AWS today. So I just want to put one question in your mind at the start of the presentation. And what if I told you that you could build a solution that was detecting, alerting, and remediating a security incident in a matter of seconds, and it was completely autonomous? That's pretty amazing, isn't it? Well, I want you to keep that in mind as you listen to the rest of the presentation. Now, first of all, I want you to ask some questions about your existing IT security. So in your existing security incident response systems, it helps to ask yourself some questions. And all these questions will start with this word: why? First of all, why is security incident response in traditional IT environments so hard? Well, this really comes down to two factors. The first of these is a lack of visibility in your environment. Who is doing what? When are they doing it? What resources are they touching? Where are they accessing your systems from? Without a common framework to log actions across all of your entire infrastructure, it's hard not only to detect these changes happening simultaneously on multiple items at once, but see what's happening and correlate actions. Now, the second is a low degree of automation. In a typical on-premises environment, you may be building some of your servers manually or some scripting. You may have inconsistent patch management, and no decent mechanism to automate common processes across all of your infrastructure in one place. Now, detecting threats in a modern IT environment is a challenge. The first issue you have is working with large data sets. So you've already enabled AWS CloudTrail, Amazon CloudWatch, and AWS config. Well, I hope you have anyway. Serious note at one point here. If there's one thing you take away from this presentation today, when you go back to your organizations, please enable AWS CloudTrail for all regions, enable AWS config for configuration history, and use Amazon CloudWatch for monitoring thresholds and alarms in your accounts. Back to the presentation. So you're collecting logs from your applications and operating systems and services, and this is our best practice recommendations. However, you now have logs which are generating millions, perhaps even billions of events on a daily basis. And this leads to the second issue, a very low signal-to-noise ratio. How do you spot that needle in the haystack? Can you pick out a series of events occurring simultaneously across multiple data sources at once? And it's also difficult to make sure that your security and development teams have the constantly updating experience and training needed for so many different systems at once. So, why do I need to put guardrails in place on my AWS accounts? Well, I hope this is self-evident, but as you build more AWS workloads and scale out across multiple AWS accounts, you need to make sure that your security is providing a safety net. And at the same time, it's not actually blocking the innovation of your developers using the AWS cloud. And finally, why do you need to build automated security remediation? Well, it doesn't matter how many people you add to your security teams. They will never be as good as an automated process. So, lock your people away from the security incident response process. Keep the humans out of the decision-making framework. Automate as much as possible. Now that we've talked about why you need to automate your security remediation, let's focus on the benefits it will bring to your organization. First of all, humans make mistakes. We all make mistakes. Eliminate the risk by automating your incident response. Automation never sleeps, it never takes breaks, it doesn't need to eat lunch, and it absolutely will not stop until your security incident is remediated. You're already deploying your infrastructure as code with CloudFormation and other services. Automated security remediation is just an extension of that process. It allows you to fix security issues as they happen, and make sure that your environment always stays in a compliant state. If your environment is under attack by malicious actors, what we'll typically see is that people will be attacking your front-end web services, and at the same time, using that as a distraction, they'll be trying to attack your back-end system simultaneously. Automated security remediation allows you to address all of these attack vectors at once, simultaneously. And automation allows your security teams to focus on high-level tasks, such as building compliance and governance frameworks for your organization, rather than constantly firefighting security incidents reactively. And of course, automated security remediation is easily built and scaled using AWS. So the key to automating your security remediation is to build using repeatable serverless automation patterns. Security events are generated by AWS services and other log sources, such as your applications and your operating systems, or firewalls, or other services that are generating logs. The events are then streamed into services such as Amazon CloudWatch or Amazon Simple Notification Service. And these event streams are then used to trigger AWS Lambda functions that have been crafted to remediate a detected security issue. So, as an example, we could use the security findings generated by Amazon GuardDuty. Now, GuardDuty is one of our recent AI ML-based security services. When you first activate GuardDuty, it builds a baseline of normal network behavior in an AWS account or set of accounts. GuardDuty then generates security findings, which get rated by severity when it detects anomalous behavior. This can include people spinning up Bitcoin mining operations in your EC2 instances, port scanning of your resources, and so on. The findings can then be streamed into Amazon CloudWatch, and these events can then be filtered using CloudWatch events, which act as the trigger for an AWS Lambda remediation function. Now, an example of this pattern would be GuardDuty detecting a compromised EC2 instance in your account that's trying to talk to a malware command and control host out on the internet. The GuardDuty finding via CloudWatch events triggers a Lambda function that isolates your EC2 instance by replacing the security group with one that has no VPC or internet connectivity. You can then later perform a forensic analysis of your isolated EC2 instance at your leisure. But that's enough of the why, and why you should be doing this. Now it's time to hear from one of our customers who have done some exciting work to improve their security in the real world using this automated security remediation pattern. Please welcome Jason Gorringe from Australia Post to the stage.
Thanks, Mike. Thanks, everyone, for coming. Good morning. It's a beautiful morning here in Canberra today. So, as Mike said, I'm from the Australia Post Cloud Services team. We've been doing a lot of this remediation work just across many various accounts over the last year or two now. And we've really got a really mature product now that we're very happy with, and it's very scalable. So just firstly, though, I'll tell you a little bit about Australia Post. We are one of the oldest and most trusted companies in Australia, so we're over 200 years old. Our customer trust is really important to us, and security is key to that. If we can't use security for our trust, then our customers aren't going to want to keep using us. A couple of fun facts about Australia Post. We're a self-funded government business. Contrary to belief, your taxes don't pay our wages, so we actually have to provide a profit back to the government every year. We have one of the largest employers in Australia, so over 70,000 employees in Australia. We have retail, parcels, and obviously our IT and support network around that as well. We're one of the largest retail networks in Australia, so we have almost 4,500 physical locations around Australia. We also have, obviously, the parcel and letters delivery facilities across all the states. We deliver to 11.9 million addresses, and we'll come back to that one in a little bit. But we also, it's not clicking. There we go. We deliver more than 1.3 million parcels every day. That brings out some real problems that Australia Post have faced over the last 10 or 15 years. Our business and our requirements are changing hugely. So out of that 11.9 million, probably 10 years ago, that was 10 million. So we've got 2 million more addresses that we have to deliver to, with probably a third of the amount of mail going to that. So most of you would know, how often do you go and check your letterbox these days, where 10 years ago you didn't do it. So our business has to evolve to compete, because once again, we have to provide a profit back to the government. So we use that using digital services, and obviously parcels is a key part of that as well. So as part of our growth and our change, we have to have obviously trusted partners that we work with that help us. And obviously, why we're all here, we love AWS. They're a trusted partner. We've been with them since 2013, so we're one of the first adopters of cloud services in Australia. That brings with it some challenges that probably Ahmed will face into later on, because we have now a cloud that's 6 years old, and I deal with infrastructure as well as cloud services for Australia Post, and I know that if a server is more than 5 years old, we usually chuck it out and replace it. So now we're looking at our AWS services. Some of those are more than 5 years old. They're the old pets and cattle, RDS, EC2 and S3. That was probably, in 2013, they were probably the only main services that AWS offered. Nowadays, we've got Lambda, Kinesis, Macy, all these great products. So we have to keep evolving, but we also have to build security guidelines around both the older IT world and the newer digital world. So moving on, how do we build? So we have an agile methodology. We have a big shared services account, which we do use. We have agile running in there, but we also have the legacy, well, not so much legacy, but the traditional IT streams run through as well. So they're all sharing the same environment, the same VPCs, the same proxies, all that goodness. We have hundreds of developers, about 300 in our digital stream, and we probably have about just under 100 IT people with including security staff amongst that too. We have a continuous integration with, and delivery with 8 to 12 production deployments roughly a day. We have co-located teams. So in that one building that we have the security, developers, IT, we have finance, and we have the business stakeholders as well, all part of that one building. It's great because it allows for collaboration and easy communication, which when we get to this bit more of how we did it, that's really important, because our ability to communicate to the stakeholders is vital. We can't just put all these controls in and expect everyone to do that, because we're going to break applications and whatnot. We literally have hundreds of AWS configuration changes every single day, and we need to track that. Like Mike said, with all those changes, we need to keep humans away. So traditionally, we've actually just put more people in. We've got more stuff coming. We just need more people to look after that. Well, nowadays we're using automation more. We're using native AWS services, which is really important. It allows us to scale. It allows us to access more accounts. We started off about a year ago. Well, not started off, but we had about a year ago about 10 to 15 AWS accounts. This product that we're going to demonstrate later on has to scale across now. We have 130 accounts in just a little under a year that we've gone and deployed. So the great thing about this tool, using native AWS tools that Mike explained before, we're allowed to scale that right out to a huge thing. That's all now part of our service catalog. So we deploy detective controls through a service catalog. So when you want a new product and you want to test it out, we give you an account that's already got detective controls pre-built into it and configured, pushing back to Sumo and raising alerts as needed. So all that gives us a DevSecOps mentality. We want to try and make security as invisible to the developers as possible. We don't want them to have to think about, do I configure it this way? It should just happen. And so it's really important that we can provide that environment for them. So the problems, or the process, I guess, to get here. So the first thing is we have to detect. So we've gone along, we've thought, okay, port 443, let's go and detect, let's see what how many accounts or how many workloads have port 43 open to the world. So we'd go through, we'd get a list, then we'd go back to the developers and say, okay, we need to actually fix these manually to start off with, because we can't put the auto remediation in until we start from, obviously, a baseline. So we assess that against what our requirements are, and that helps us set the baseline. So now port 43, whenever we deploy a workload, it automatically remediates, which is the next one. So once we've established that, we've communicated with the stakeholders, we've communicated with the developers, we need to then take action. So we've either got the choice to remediate or notify, or in some cases, we'll do both. So we'll actually remediate the issue, and then they can get notified via Slack, ServiceNow, so we integrate fully with ServiceNow to create an alert in our queue, which we then can assign to the developer group, or email, obviously. So some of the examples we went through, and like I said, this is not a big bang thing. We want to bring these changes in incrementally, and we keep growing. This product that we've got now is evolving continuously. We just did a deployment and an upgrade of it last week, and we've got another one planned next week. So every week we do another step upgrade of the detective controls. So security group ingress roles, that was one of the first ones we went through, port 443 and 22, as Ahmed will explain later on. CloudTrail configuration changes. Obviously our CloudTrail logs are really important. It tells you everything that's going on in your account. So as soon as someone starts tampering with them, you want to know about it. So also, we want to know about config changes as well. Route table changes or any networking changes. Part of this that we've just released, I think this is the one we released last week, was adding, deleting default VPCs and security groups out of accounts, so it just automatically just does it. And as soon as someone spins it up, we get an alert to say this has happened, and it'll auto-remediate it straight away. And finally, Aureus Rds Encryption. We're a big user of RDS, so we want to make sure that data is secure and encrypted. So we have certain rules in there now that we're deploying that make sure that all that data is encrypted, and we're alerted. We don't necessarily auto-remediate on that, but we do detect if it's not. So without further ado, I'll pass you on to Ahmed, who will go through a bit more of the techie stuff for you, and explain how we do it, and how it integrates with ServiceNow. Thank you, Ahmed.
Thank you, Jason. Good morning, everyone. Trying to click. Yeah. I'm Ahmed. I'm from the Cloud Security Engineering team. I'm going to walk you through one of the actual use cases, enforcement of security group ingress rules. Before I start, let me set up the scene for you. Let's pretend I joined Australia Post last week. I have been onboarded on Slack and AWS accounts. And as I have joined only recently, I don't know all the security best practices and the policies that Australia Post follows. So today, I'm going to work in a private subnet. I have a security group, and I have to add some roles in there. So let's go back to the console. Let's go to the console. Yep. So the security group that I'm working on today is called AWS Demo. As you can see, there is no ingress rule at this point. This security group is attached to our EC2 instance in a private subnet. So let's start adding the roles. Let's start with port 443, which is HTTPS traffic, and I'm going to open it to the whole IPv4 ranges so that this port can be accessed from any IPs. The next role I'm going to add is port 3306, which is the MySQL. Now, I need access on this port from other instances within the same subnet or the same VPC. But today, I'm just feeling a little bit lazy. What I'll do, I'll go ahead and just open up this port to the whole private subnet of 10 series, because the VPC range will be in somewhere within these IP ranges, so that should be OK. The next thing, I'll open up also port 22, and I'll open it to the whole world again. And let's save. So here are the rules. SSH is open to public IPs. Port 3306 is open to whole private ranges. Suddenly, I got some kind of alert there. I'll go and back and see that Slack notification. Now, I know what you're thinking, that port 22 is open to the world is not a good practice. But as I mentioned earlier, I'm working in a private subnet. It means there must be a network access control list which allows traffic only from private IPs. So even if I open up port SSH to the world, it doesn't matter because no one can from public IP or outside of OSPOS network can connect to this EC2 instance. So before proceeding further, let's refresh. And suddenly I see a couple of my roles are gone. In a real life scenario, I'll probably try out the roles again multiple times before I go and ask someone, my colleague Jace, on Slack, what's happening. So let's go to the Slack. On the Slack, I see there is an alert. So let's go and see. The alert says security group policy violations. The following are open to large network, SSH and TCP 3306, and auto remediation has been performed. Region is AP Southeast 2. Account alias is the same account that I'm working on. And the resource ID is the AWS demo, the security group that I was working on. My user ID is there. The time of the event is also there. It's 9:20. It's just today, right now. And the roles that have been revoked is port 3306 and port 22, the exact roles that I added. Soon, someone from the security team will get in touch with me and help me understand what happened, why these particular roles have been revoked. They will inform me that I cannot open any port except 443 to a large network, because even if it's a 10 series is a private subnet, that involves a lot of many parts of the networks. Let's say it can be retail, it can be even the locker system. So we should not be providing access to those from those particular IP ranges. We should be very specific from which IP ranges or which security groups we should be allowing traffic. So what happens? Let me take you to the presentation slides so that I can show you our solution. The solution. The first thing is about detection. As JC was mentioning, and Michael also was mentioning, that there are so many logs, so many places, so many configuration changes. How do we detect the configuration changes? Now, as Michael mentioned earlier, we really should be enabling CloudTrail in every account, because CloudTrail captures all the API calls. The moment I click that Save button, I actually generated an API call, Authorized Security Group Ingress. And that API call gets logged into CloudTrail. Now, we have the API calls in the CloudTrail. How do we analyze those API calls near real time? And that's where the CloudWatch event comes into. CloudWatch event provides us, helps us to define roles, event roles, by which we can generate real-time events out of the CloudTrails. For this case, whenever I click the Save button, the API was generated, Authorized Security Group Ingress, and the CloudWatch event generates an event for that. And that event gets forwarded to our assessment layer. In the assessment layer, we have a Lambda and an SNS topic. The event gets published to the SNS topic, and the Lambda is invoked through the SNS topic. Once the Lambda or the assessment layer receives this particular event, it identifies the account from where this particular event was generated from. Now, every account is different. There is production accounts, non-production accounts, sandpit accounts. So for different accounts, we can have different kinds of policies. And to store these policies, we use DynamoDB. The Lambda collects account-specific policy from the DynamoDB, analyzes the event, and decides what to do. For this particular demo, the Lambda decided to revoke those particular roles, port 22 and 3306. Once the assessment layer makes a decision, it forwards the event to our remediation layer. Remediation layer, again, is a couple of essence topic and Lambda are there. Just on a side note, all our Lambdas are invoked through SNS topic because of fault tolerance. The remediation layer Lambda will assume a role in the source account, perform necessary remediation. Our remediation for this simple case is that it will revoke those particular roles through revoke security group ingress API call. Once remediation is performed, the event gets forwarded to our notification layer. In the notification layer, we have multiple Lambdas and SNS topic and a S3 bucket. The notification layer may assume another role in the source account and collect more information about the resource. Because we want to know what was the configuration before the remediation was performed and what is the current configuration after the remediation was performed. Then the notification layer publishes the short summary report that you have seen to the Slack. And a detailed report gets dumped to the S3 buckets. Sumo Logic collects this detailed report, and through Sumo Logic, we have integration to ServiceNow, and the ServiceNow generates the ticket to the relevant group. So for us, guardrails are not only about protecting the environment, it is also about educating our users about security best practices. Using the ServiceNow and Slack alerts, we identify which users are doing the changes, and we help them to improve their way of working, to include security in their thinking process. Even if it is a proof of concept development or whatever it is, everyone really should be thinking about how to follow the security best practices. So let's go to the console, and let me show you some sample code using which you can easily develop your own solutions. So the first thing is about defining the CloudWatch event. This is a sample CloudFormation template where the resource type is the events role. The main thing here is the event pattern. In the detail type, we have to mention what kind of events we are looking for. It can be events from the AWS config. It can be specific resources. In this particular case, it is AWS API call via CloudTrail. Now, we know that security group is a resource of EC2 service. So the event source will be EC2, AmazonaWS.com. The event names are nothing but the API calls. All these are API calls related with security groups. Now, you can define, you can include security, API calls that you want. I just put all of them here. And state is enabled. In the target, I have mentioned our SNS topic here, but it can be your event bus also here, or your Lambda directly. But I would never suggest to send a CloudWatch event directly to a Lambda. Now, once we define the events, we really should need to understand what is the data coming in. Here is a sample CloudWatch event. I have only highlighted the main parts here because the CloudWatch event has more information. I have just included the part that we really need. So the detail type is, again, AWS API via CloudTrail. Every CloudWatch event will have the account ID, which is important for us. Because using this, we can identify which account this particular event has occurred, and we can use that details to go and perform the remediation. In the detail, we have the user identity, type of user, and the user name. It also includes ARN and other information. Using these details, we can actually go and identify the exact user who is performing these changes. The event time, the event source, and the event name. The event name is, again, the API call the user is performing. The region is there. The source IP address of the user. Is the user is doing this work from your office network, or is it doing from home or from somewhere else? The user agent is the way the user is interacting with the API service. Here it is signin.amazonaws.com, which means the user is using the console. But if he is using SDK, like Boto3 or Go SDK, the SDK name and the version will be there. In the request parameters, we have the exact roles the user is using. The group ID, the exact security group the user is performing the action. And in the IP permissions, we have the roles that he is creating. For this example, this IP protocol from port to port IP ranges. IP protocol is TCP from port 22 to port 22. It means just one single port is getting opened. And the CID pair IP, from which IPs this traffic will be coming in. And we also have the response elements, which is return true, means this is a successful API. This is also quite important because you may not want to analyze failed events. You may also want to identify users who is performing actions, trying to perform actions that they are not supposed to. Now, once we have the events, let us have a look into this policy. This policy can be as simple as this. You have an account ID, and you have a key call up into the world, which is 443. I mean, this is a very simple policy, but you can always play around and build it as you need for your organization. Now, policy, you can hard code in your code, but that's not a really good idea. If you want to store in DynamoDB, account ID is a very good candidate for partition key. Now, how do we make the DynamoDB query? Again, this is very simple. It's just input the boto3. We create a DynamoDB resource. Then, using the table name, we create a DynamoDB table object. The query is table.getItem, where we provide the key. The key is, partition key is account ID, and the value of the account. And this account value is coming from the CloudWatch events. From there, we get the policy. Now we have our policy, we have our event. So let's move to analysis. As part of the analysis, what I'm doing here is I'm creating a list for roles to revoke. At the first stage, I'm analyzing the authorized ingress API call. Now, if you remember, in the event request parameters, a user can have multiple roles within the same API call, which is this, multiple items. So we really should be iterating over them and go one role at a time to identify whether that role is deviating from our security policy or not. So for each item, I'm detecting the protocol IPv4 ranges from port and to port. Now, IPv4 ranges itself is a list, so let's iterate over through it. And if it is equals to 0.0.0.0, which is the public IP, open to the world, let's analyze the port range. In the port range, considering our policy is so simple, it's that a single port is there. If neither the port, if either port, from port or to port does not match with the policy that we mentioned, which is 443, we are going to set that to remediate. In the set roles to remediate, we are going to append to roles to revoke with this particular dict format, where IP protocol is protocol from port to port and IP ranges. This is coming from the boto3 API call. So boto3 has revoke security group ingress API, where you have specific format to provide. So I'm just structuring this information in that way. Now we have identified the roles to revoke. We move to revoking the role. As you can see, all we need to do is create an EC2 client using the boto3. And using the boto3 API revoke security group ingress, we provide the group ID. The group ID is coming from the event again. And IP permission equals to roles to revoke the list that we just generated. After the remediation is performed, if you want to publish to Slack, I mean, Slack has really good documentation on their web page. But here is just a simple example. I'm importing the Python request module. In the Slack message, the text is the security group policy deviation, which is basically this particular line. And in the attachments, we have different fields. For this example, I just included alert, region, group ID, and user ID. You can structure it based on your own need. And performing the Slack action is as simple as that, putting request.put, providing the Slack URL, and the Slack message. Now, one thing to note again, the ServiceNow ticket is quite important for us. Because with the ServiceNow ticket and with the Slack alert, we try to improve our way of working. We really don't want to auto-remediate anything. Ideally, we want people to solve this issue at the very beginning. I hope this simple example helps you in your journey of auto-remediation. We can really have lots of fun with auto-remediation. We can generate customized policies for every little different accounts. And it can be very complex or as very simple as this. I'll hand over to Jace now to walk you through outcomes and the challenges that we faced. Thank you.
Can we go back to the slides, please? Thanks, Ahmed. That's awesome. Just before I sort of move on with this, which probably talks to the first part of the outcomes here. When these guys presented in Sydney Summit, and when they first presented, we had 3 accounts covered under detective controls and auto remediation. We've moved that now to 120, so about a month ago. It's about 60 now, but we've got 120 coming. So about a month ago, I went to Ahmed and I said, look, this product's awesome. I want to deploy that as part of my baseline, part of our service catalog offering to everyone that has an AWS account now. And within a week, he had built that and integrated with using code pipeline, stack sets into our service catalog. And now we have 60 accounts that are covered with detective controls. Then the week after I asked that from him, I said, that's great, I want to know where that stuff is. So I want to know what accounts are compliant by my baseline. So now, using detective controls, he's actually built me a product called Account Insights that goes in, queries the account, and tells us whether it's got CloudTrail enabled, it's got CloudWatch logs, config rules, all those stuff, all the important things that we need to make sure that an account meets those certain criteria and certain baseline. He's been able to integrate that into our service catalog. So it's amazing, amazing work and really good product, adaptable. And once again, like I mentioned earlier, using an AWS native tools is very important. Which probably talks to the first thing. The great thing about this, we've improved coverage. Our compliance levels are through the roof now, and it's easy to track that. It's a lot easier to track it. We've been able to reduce the time to remediate. So normally when we're throwing people at the problem, it's very hard to do. So now what we can do is we actually, auto-remediate, or they get an alert straight away. They get a ServiceNow ticket straight away, which really helps us take some time out of my team's time to actually go and ring these people up and ask why they've contravened the rules that we've set. Increasing transparency and more engaged delivery teams. Part of this is collaboration. We can't just go and put all these rules out there and expect everyone to go along with it. We actually have to talk to these teams and bring them along the journey. It's really important. They have to be part of it. And now we're finding out other teams are out there and saying, hey, can we make this part of your detective controls? We think this is a really important security measure. Can we put this into your baseline? So having that communication and collaboration with other teams is vitally important. And security and governance has always gotten a bad rap, but now we're actually finding that people are coming along and realizing the value that it can add. It's also scalable with extremely low operating costs. Using, once again, AWS native tools. We go out and buy a product that does this, it costs thousands of dollars a month. Now we're doing over 70,000 checks and growing per month, and it's roughly about $5 a month, the cost to run this product. So it's an amazing feat, and the great thing is we can just keep adding to it, and the cost only goes up a tiny little bit. I guess for you guys, the challenges that we faced, we had to set, and we still have to keep setting mature, established security baselines. So it's really important that we have that available for all the delivery teams to go and see, what are the standards that we're setting for them when they build. It's really important, and it's got to be easily accessible to those teams. Stakeholder communication and management. So those dev teams, like I said earlier, we need to communicate with them, we need to collaborate with them, and we need to work with them so that they can build better practices, which comes into the developer education program. If you get the chance today, our CIO is presenting on an education thing this afternoon. And we've found that investing in the education through AWS training and stuff like that is hugely important. But also not just with formal training, but also other workshops that we run quite often. It's really important that we do those things together and we're all on the same journey, even though we're running from different teams and running probably completely different workloads. And finally, the ability to influence upstream changes has been really difficult, but we've found that now that we've sort of hit that speed bump and we're going forward, it's been really good. So we're actually seeing now much better practices. Teams are actually doing the right thing without having to be told. I feel like it's like, you know, when you're crossing the road and you see that green man, you just expect that the other way, there's a red light there, right? Because it's automation, and you trust that. So our developer teams are those, you know, waiting for that green man to cross the road, but they're hoping that when they're trusting that we've got the automation in the background to stop the traffic and stop all the security risks that might be coming to them. So in saying that, I'm going to hand you back over to Mike, and thank you very much, guys, for listening to us speak today.
Thanks, Ace. All right. So I think you'll agree that it's an incredibly compelling story from Australia Post at a very low cost point, extensible, expandable, easily implemented security remediation patterns that you can build in your organization using AWS native services. Now, we just have some call to action points for you when you leave here today. So first of all, I'd like you to think about adopting this automated serverless remediation pattern into your existing workflows. As part of that, look at putting the output of other AWS monitoring and security services, such as Amazon Guard Duty or AWS Security Hub, AWS Config, into the same pattern that you've seen here today. Look out on the AWS Security blog and also on our Amazon Quick Starts, which are CloudFormation templates you can deploy with pre-configured environments into your AWS accounts. The Guard Duty example I talked about earlier is actually available on GitHub and as an AWS Security blog post, so we can deploy that sample of a compromised EC2 instance and having the automated remediation of isolating it via the security groups. And please go build. Let us know at Australia Post and at AWS what you've built. We'd love to hear from you. Jason, Ahmed, and I will be available at the end of the session for you to ask us questions. And thank you very much for your time. I hope you have an awesome time for the rest of the day here at Canberra Public Sector Summit. And thank you for listening to myself and also my guest speakers from Australia Post, Jason Gorringe and Ahmed Al-Anim. Thank you very much.